Hello fellow humans, and welcome to the third video in my series, All the Logic Needed for Logic Game. By now, you should feel comfortable with the conditional and the contrapositive, and you should be able to find the contrapositive of any simple conditional simply by applying our process. You've also picked up a few tricks along the way to simplify contrapositives. In this video, I want to address an area that can cause a lot of headaches. DeMorgan equivalencies. Both with my clients and with what I see online, it appears that these can present big problems. But in reality, they're not that difficult to understand, and even better, you can simply memorize these too. After this video, you should never have to struggle with these on the LSAT again. Alright, let's get started. In a normal conditional, the antecedent is a single variable and the consequent is a single variable. For instance, you might have something like this conditional here, if R then H. And by now, taking the contrapositive of this conditional should be pretty simple. And the contrapositive is... Remember, first we reverse, then we negate, and finally we form the conditional of these two variables. But what about something like this? If R, then H and M. How do you take the contrapositive here? R is simple enough. The negation of R is just not R. But what about the expression H and M? How do you negate that? Because you're not just negating one variable, you're negating a whole new expression. And that expression has its own logical operator, in this case conjunction. So that poses problems when we want to negate that expression. If I were to write it out, it would look something like this. The original conditional, of course, would say if R, then H and M. And the contrapositive, if we were to write it out, would say if not the case H and M, then not R. And once again, not R is fine, that's no trouble. But what about not the case H and M? What about that? What does that mean, and how do we carry out that negation? That's what we're going to learn to do in this video. And just like before, I'll give you the quick guide, the memorization strategy, and then I'll go into explaining the reasoning behind the strategy. So first, the strategy. Now I want you to repeat after me. The negation of a conjunction is the disjunction of the negations. One more time. The negation of a conjunction is the disjunction of the negations. And just in case these terms are unfamiliar, conjunction means and, disjunction means either or. So to negate an expression like H and M, just remember, the negation of a conjunction is the disjunction of a negation. And that's all you need. So let's look again at our conditional. If R, then H and M. And let's go ahead now and take the contrapositive. The R, of course, is easy. Reverse it, put it over here as the consequent, negate it, and there we go. Now let's take care of this expression H and M. The negation of that conjunction is the disjunction of the negation. So first, let's convert this conjunction to a disjunction. And we're going to use this symbol V to convey a disjunction. And we use V because it stands for the Latin word vel, which means or. So alright, we replace the conjunction with the disjunction. That's this V right here. Well, disjunction of what? Disjunction of the negations. So we put H and M on either side of the V and negate each one. So the negation of a conjunction is the disjunction of the negations, which looks like this. Form the conditional once again, and we have our contrapositive for this expression. Either not H or not M, then not R. And as we've learned in previous videos, what's on the left cannot go together, what's on the right can go together. And just like that, we're done. Just that easy. Alright, so that's the process for conjunction, but maybe you see something like this. Maybe instead of a conjunction, the expression you have to negate is a disjunction. As for instance, in this expression, either B or C than D. And once again, we're faced with the same problem when we try to take the contrapositive. Negating D is easy. The positive goes to negative, D goes to not D. But what about this disjunction B or C? How do we take the negation of that disjunction? Well, once again, we have a nice little expression, so repeat after me. The negation of a disjunction is the conjunction of the negations. So let's take a look at that conditional again. B or C, then D. Now, we go through our process again, and once again, D is pretty easy here. We just reverse it, so now it becomes the antecedent. And D is positive, so we negate it, not D. Great. But now we want to apply this statement, the negation of a disjunction is the conjunction of the negations. Now I'm going to take a moment and let's see if you can do this on your own, or just pause the video and give it a shot. See if you get what I get here. All right, you ready? So first, we convert this disjunction to a conjunction. So we put that here. And then we take each variable and negate it. So we put the B here, we negate it. We put the C here, we negate it. We form the conditional between these two expressions, and that's our contrapositive. Is that what you got? If so, give yourself a gold star, or a drink, or whatever. And that's it. That's how we negate conjunctions. That's how we negate disjunctions. And those are the DeMorgan equivalencies. And so let's just put them together. The negation of a conjunction is the disjunction of the negations. And we learn that that looks like this. The negation of a disjunction is the conjunction of the negations. And we learned that that looks like this. And we call these DeMorgan equivalencies. We call them that because of this guy right here, Augustus De Morgan. And though we attribute these equivalencies to him, though we've named them after him, he didn't invent them. I suppose you could say he discovered them, and we do attribute them to him. But bear in mind also that this guy up here, Aristotle, he was aware of these equivalencies 2,000 years ago. And so was this guy, William of Ockham, a philosopher of the medieval period. So it's not as if these DeMorgan equivalencies were entirely unknown to logic. They've been around for thousands of years, but the work that De Morgan did on these means that we now call these equivalencies DeMorgan equivalencies. Okay, so what's going on here? Why do these expressions help us to translate conjunctions and disjunctions? So once again, to demonstrate the reasoning behind these, we're going to look again at our Venn diagrams. So we're going to make two circles. And this circle on the left is going to be H. This circle on the right is going to be M. And where they overlap is where we would identify the expression H and M. So if I have the set of all things H and I have the set of all things M, then the expression H and M means that that's going to be represented with a check mark right here where they overlap. Now let's put together the whole visual picture. When they're both true, there's a nice little check mark in the middle. That says H and M. But suppose we put it over here to the left. So this would mean H is true, but not M. Is the conjunction still true? And of course the answer is no. So for instance, I might say of myself, I am blonde-haired and blue-eyed. Now what's required for that conjunction to be true, blonde-haired and blue-eyed? What's required is that I am both of those things together. I am blonde-haired on the one hand, I am blue-eyed on the other hand. Although I don't know if I can still call myself blonde-haired when I'm losing all of my hair. I'm very nearly bald. My head looks like somebody blew all my hair off like a dandelion. But insofar as it is true that I am blonde-haired and I am blue-eyed, then in that case, both have to be true. But if only one of them was true and the other was not, then of course the conjunction would have to be false. So in our present case, if H is true, but M is not, then the conjunction is false. If M is true, but H is not, then the conjunction is false. And of course, if neither H nor M is true, if they're both false, then of course the conjunction is false. And all of that accords with our everyday understanding. If I'm only blonde-haired but not blue-eyed, then it isn't true that I'm both blonde-haired and blue-eyed. And if I'm only blue-eyed but I'm not blonde-haired, then again, it's not true that I'm both blue-eyed and blonde-haired. And of course, if I'm neither one of those, then the conjunction is also false. So why am I talking about this? Well, let's look once again at our equivalency. It says the negation of a conjunction is the disjunction of the negations. And now I want to rewrite that in terms of truth or falsity with regards to a conjunction. So, based on our Venn diagram, we would say a conjunction is false when either of its conjuncts, either H or M, is false. You'll notice that both of these statements say the same thing, the negation of a conjunction. In other words, a conjunction is negated, a conjunction is false when either of its conjuncts is false or there is a disjunction of the negations of each variable. So the DeMorgan equivalence just expresses the negation of a conjunction in terms of its truth values. And you know, that's really one of the innovative aspects of these DeMorgan equivalencies is that instead of negating the operator, the conjunction here, we're interpreting that in terms of the negations of variables. But okay, that might be too much. All you need to know is that the negation of a conjunction is the disjunction of the negations, and one way to remember that or to see that is to recognize that in terms of truth values, that's just equivalent to saying what is intuitive to all of us, that a conjunction between two things is false if either one of those conjuncts is false. So the conjunction blonde-haired and blue-eyed is false if I'm either not blonde-haired or I'm not blue-eyed or I'm not both. And so with that intuitive understanding that we have about when conjunctions are true or false, they're formalized in this statement of that equivalence such that the negation of a conjunction is the disjunction of the negations. Or in everyday intuitive language, a conjunction is always false if either one of the conjuncts is false. That's pretty cool, right? Now let's take a look at this other DeMorgan equivalence, the negation of the disjunction either B or C. And just like before, we're going to use our trusty Venn diagram. So we're going to make two circles. The one on the left is B, the one on the right is C, and we're trying to understand the expression either B or C. Now, if you remember our discussion at the end of the last video, you remember that I told you that on the LSAT, the inclusive sense of the disjunction is the one that they go with unless they specify otherwise. And so let's think about what that means here. On the one hand, the expression either B or C is true, obviously, if either one of them is true. All right, so suppose that I say that I am going to visit my friend either Tuesday or Thursday. Under what conditions would that type of disjunction be true? Well, there are exactly three. If I go Tuesday, then it is certainly true that I went either Tuesday or Thursday to see my friend. If I go Thursday, then it is certainly true that I went to see my friend either Tuesday or Thursday. And in an inclusive sense, the disjunction is still true if I go see my friend both Tuesday and Thursday. Why? Because it's at least true that I went either Tuesday or Thursday. The inclusive sense of the disjunction is always implied. I can go Tuesday, I can go Thursday, I can go both Tuesday and Thursday, and the disjunction is still true. There is only one condition under which that disjunction is false, and that would be if I go neither Tuesday nor Thursday, but instead, let's say I go Friday. If I go Friday, then the disjunction is clearly false, because it's not the case that I went Tuesday, and it's not the case that I went Thursday, and therefore the expression as a whole, I will go see my friend either Tuesday or Thursday is now false. So we put a check mark here on the B side, we put a check mark here on the C side, and of course a check mark goes in the middle where they overlap, because if both B and C are true, then it's still at least true that one of them is true. So the expression either B or C still works just fine. So let's look again at our expression of the DeMorgan equivalence for negating disjunctions. The negation of a disjunction is the conjunction of the negations. And I could rewrite that to say a disjunction is false when both of its disjuncts, B and C, are false. And of course, just like with the video on contrapositives, remember that logical negation switches the truth value. So if a variable is negated, then its negation is positive. And what I've tried to do here is just sort of show you that these DeMorgan equivalences are not big scary things. They just respond to the intuitive way that we think. Because it seems pretty intuitive to us that a disjunction is going to be true if at least one of the disjuncts is true. And that means that it seems pretty intuitive that a disjunction is going to be false only if both of the disjuncts are false. And those are our DeMorgan equivalencies. Now, I want to be really clear about this in regards to the LSAT. These are the only two negations of an operator that you're ever going to see on the LSAT. The only types of negation you're going to see are negations of conjunctions and negations of disjunctions. And those are covered by these two DeMorgan equivalencies. You are not going to see a negation of a full conditional. You are not going to see a negation of a full biconditional. You are only ever going to see on the logic games portion of the LSAT the negation of a conjunction or the negation of a disjunction. And again, those are covered by these easy to remember phrases. All right, I hope that helped break down DeMorgan equivalencies for you, and keep watching.